We will discuss on the topic of credit card fraud detection. Credit card frauds are a big problem in the world. Simply, when someone is able to access your credit card and use it to make payments from your account for malicious purposes, it is a credit card fraud. You can see that residents of China, the US, and India, all very big nations, have experienced this problem very frequently. Also, this is causing people to lose faith in financial institutions or banks. There are many ways in which fraudsters get your card details, some of which are listed here. As you can see, there is a wide range of methods employed by fraudsters to get to your card details. So for example, if you are driving to work and your car shows the low petrol indicator, you will realize that in order to safely reach your office, you will need to refill the fuel. So you pull over at a petrol pump and have the gas refilled. Now, once the gas is refilled, you need to make the payment. So you decide to use your card. Now, since you're getting late to office, you're in a hurry. You don't, you are not that aware of your surroundings, and you don't make sure that no one is able to see what pin and details you're putting for your card. And in this hurry, some person behind you is able to see what details you used. This person uses your details to access your account and withdraw money. You are unaware. On so when you are finally on your way back from office, you are alerted by the bank that someone has withdrawn and made away with money from your bank account, or you will find out that someone has made away with the money, and you will then inform the bank. So at the end of the day, you have become a victim of a credit card fraud. Now, since this problem is so widespread, banks have taken steps to ensure that such transactions are prevented. The method most commonly used is the data of previous transactions is stored and regularly updated. In this data, we have the account number, transactions amount, transaction location, etc. of previous transactions, along with the label, whether it was a fraud transaction or not. Then, some employees are hired to detect fraud transactions and prevent them. These employees are trained on the data and learn what conditions indicate a transaction being a fraud. So, after studying, they learn to identify some signs which help them identify these fraud transactions as they are taking place. Then, these employees are tested. They are given only the details of the transaction but not the actual result, and are told to predict whether a transaction is a fraud or not. Then, the group of employees who is good at detecting these frauds and makes the least errors are selected by the bank for this task. They then analyze transactions in real time and stop frauds before they have been completed. So back to our case where you paid for your fuel using the credit card, and the fraudster who has identified the petrol pump as a place where people regularly use their cards to pay peeps and get your credit card details. Then using these details gets access to your account. He tries to withdraw cash, however, the group of employees find the transaction to be very similar to a fraud transaction and prevent it from completing. They lock the account to prevent any money being withdrawn and alert the bank so that the details of the account and card can be changed to prevent this fraud from making away with your money. However, there is a list of problems with this solution. There are millions of transactions taking place every day, and the amount of manpower required to solve the fraud problem is too much. The process is far from fast enough since the employees have to go through so much training, and despite that, some of them fail at the tests and have to be dropped. Also, the amount of data to be handled is enormous because once again, there are many transactions happening across the world. And finally, despite all this, the accuracy of the employees of tracking down these frauds is only 60 to 70% since they are humans, and humans at the end of the day who have to go through a lot of transactions, so they can only spend a limited amount of time on each transaction, which will result in errors. So what is the solution to all of these problems? Machine learning. Machine learning is the process of teaching a machine to analyze past data and identify patterns in the data which it can use to predict the future. The first step in this process is called data collection. To train the machine, we need to provide it with data, and that data has to be collected or accumulated from somewhere, either online or in person or by using already available data from online. Next comes data cleaning. The data is usually in an unorganized format with empty values, unrequired variables, outliers, and imbalances in the data. We need to sort and clean the data such that all these problems are solved, so our machine learning model can understand our data with optimum accuracy. Next is the model building, where we call the model from the library. There are many machine learning models, and each has its separate set of strengths and weaknesses. We need to identify which model should be used in this situation, import it, and declare the essential parameters using which the model will function accordingly. Next, we need to train the model on a part of the data. This is our training data. Just like us humans, the model is first allowed to study by giving it the features and results or answers to each data record. Then, once the model is sufficiently trained and has identified patterns in the data, the model is given a test set, which has only the features, not the results, and the model is asked to predict the results. Once it has made the predictions are tested and the model adjusts itself based on the error it makes to improve itself. Then the model is ready to be used in real time. By implementing this model, it can do tasks done by humans at identifying fraud transactions, but only faster and with more accuracy. So, what are the use cases of such learning algorithms? Voice assistants, which analyze. Oh, okay. So, the way this works is the machine learning model will verify the transactions just like a human. It finds the transactions as patterns similar to a fraud transaction, logs the account, and alerts the bank so that you can change your credit card details. So, what are the use cases of such learning algorithms? Voice assistants, which analyze how humans speak and learn to replicate them, and can hold intelligent conversations with us. They can detect frauds by comparing past frauds with current conditions. Self driving cars can be created, which are programmed to drive themselves by following a set of rules and applying them to the current situations. It can be used in healthcare to analyze patients and help with correct diagnosis. But there will be a list of challenges that we will be facing in this project. So, what are they? Firstly, imbalanced data. Imbalanced data is when you have many records of one category but few of the other. For example, in our case of fraud detection, you will have, for example, 10,000 clean records and only 100 fraud records, which means 99% of the data is clean. Since frauds are much rarer when compared to the number of global transactions going on in the world every day. So even if your model predicts every record to be clean, it will have a 99% accuracy. While in actuality, it is a very bad model since it could not detect any of the frauds at all. Next, to capture the trends across so many variables. Due to there being 30 to 40 variables, how will our model be able to use every variable optimum in an optimum way to predict the data? Our model will need to establish the relation between every variable and our target. Thirdly, variables with larger values are given more influence over the model as they are given higher importance, since for a machine learning, 1000 is bigger than 100 no matter what the context. And finally, we require at least a 90% accuracy. So how will we create a model that is that accurate? Here I have given an overview of how our model will work. First, we will import our data from the CSV file. Then we will scale our unscaled values, oversample using Smote. train our neural network, and evaluate our neural network accuracy. Don't worry about these terms, they will be explained shortly. So our first step will be scaling, which is used to get all values of a variable in a specified range, for example between 1 to 0. To do so, there are three main methods. We will discuss about all of them, their respective pros and cons, and which one we will be using. So let's first understand why is scaling necessary. Scaling is necessary as normally our machine will consider higher values as more important than lower values. Simply, larger values as more important than smaller values. This will result in a variable which is not that good at predicting the end result as being given more importance just because its size is larger. Once scaling is applied, all the values of every variable get set in a certain range. This prevents any equality in the way variables are treated. This range can be between 0 to 1, though in some cases it rises as high as 0 to 3, and in case of negative values, minus 3 to 3. Standard scaler uses the mean and standard deviation of the data to transform all values to scale values. This method suffers from an outlier problem. Min-max scaler uses the highest and lowest values to scale the variable between 1 and 0. There are no negative values in min-max scaler. The max value is converted to 1 and the min value is converted to 0, and everything else falls in between depending on whom it's closer to. This method is even more susceptible to outlier problem since the highest and lowest values are given a lot of significance in these methods. Robust scaler, on the other hand, uses the 25th quantile and 75th quantile values to scale the variable. The new scaled values fall in the range -1 to 3. We will be using robust scaler as it is unaffected by outliers. So the way robust scaler works is that it arranges the data in an ascending order, and the middle value here in this new set of ascending values of our data is the median. It takes 25%, it goes 25% behind the median and takes that value as the 25th quantile value, and goes 25% ahead of the median and takes that value as the 75th third quantile value, or the 75th percent value of the ascending values. This is so the value from the first quantile to the third quantile is called the interquantile range. Then, using the values of these ranges, it scales the rest of the values. So it subtracts every new value by Q1, or the Q1 value, which is the 25th percent value in the ascending data, then divides it by the difference between the 75th percent value and the 25th percent value. So x minus quartile 1 divided by quartile 3 minus quartile 1. To code this, we will need to import our robust scaler from sklearn.preprocessing. Then we will save it to our RBS function. We are only scaling date and time columns since our V1 to V28 columns are already scaled. Next, we separate the columns we want to scale them, and then replace the unscaled columns with the scaled ones. Next, to deal with our imbalanced data, we will obviously have to balance it, and there are once again three main approaches: undersampling, oversampling, and oversampling using SMOTE.